Our next speaker is Ms. Boluwatito Aiyepola. She's a chemical engineer by training and BASF West Africa's urban miner. She works on sustainability, circular economy topics in country clusters like West Africa. And bringing to life, she drives opportunities and deepen impacts of circular economy for a total value of society's perspective.
Thank you. So once again, good morning to our royal fathers in the house and to our distinguished audience. So today I'm going to be talking us through the materials perspective of sustainability and sustainable development. So I have a couple of slides that I've put together just to support the conversation as I go. Okay, I'll stand here. Next slide, please. Okay, so this is a diagram that really puts into context what we see around us. So somehow, these cities, which someone described as the epitome of man's mastery over his environment, so people live together in comfort, in betterment of civilization, in improvement of the quality of life of humans, right? And we consume resources that flow then, previous slide please, resources that flow then through the society. But then where do these resources come from and where do they go to, and how does all of that affect the natural environment and natural ecosystems that support us? So recently in 2022, it became very clear the link between how we use materials, the materiality of civilization, and the influence that has, direct connection that has to the degradation of the environment that sustains human life. And this chart just goes through it, talking about gigatons of materials that we use. And we, of course, you might have heard of some of the consequences of the way that we've been producing and consuming so far. There are, just to think about it from an environmental perspective, there are 9 planetary boundaries beyond which, if we exceed them, there will be then dire consequences, extreme weather events, and the likes, right? And we've tipped about 6 or thereabouts of them, and we continue to get closer and closer and closer to making it worse in a way that it becomes irreversible. We're now talking about global boiling, not just global warming. And it seems, okay, well, it's getting a little bit hot here, but then it doesn't mean it's going to be that hot. But then what's important to look at is that there are several systems that are connected in supporting trade, in supporting business, in supporting enterprise. And when we breach or disturb those systems, then there are adverse consequences that we will suffer. Now it's not might, it's we will. Okay, if we'll go to the next slide, please. So on the next slide, I then also put together a visualization on so far how production and, a visualization of how so far production and consumption has worked, where we take, we make, and we throw away or we waste, right? And we know the whole spiel of reduce, reuse, recycle, that's what's going to make us more sustainable. But it goes beyond just parroting the words. It goes beyond rethinking what we use and what we consume and what consequences those really have. So in light of these dire consequences, we put together all the science on how can we, is there really a path forward? And one of the solutions that has emerged from trying to find give a definite answer to the problem is the circular economy. Now, the circular economy is a system that allows us move away from taking from the environment, making what we need, and then discarding that as waste that the environment, the natural environment cannot recognize and so cannot use to regenerate those resources from us, to one that is regenerative. And the key element in this is, can we then use resources that are already in circulation, bearing in mind that every time we extract from the environment, we're not only depleting resources, but we're also then causing unintended consequences. I spoke earlier of the 9 planetary boundaries, right? We affect those significantly when we extract fossil feedstock, for example. So a circular economy really comes and brings a different perspective. And I'd like us to note that this goes beyond recycling. I think there's a general recycling bias that, oh, as long as I can make it and recycle, oh, I use recycled content, I'm sustainable. That is just scratching the surface. There's so much more. There's regeneration. There's design for the end of life in mind. Do we really still want to have end of life, or do we want to keep those resources then in circulation so that we are not, again, triggering those unintended consequences? Next slide, please. Okay, so I just thought this would be useful for my audience, the audience that is the students among us today. So how did I get here? BASF is the largest chemical company. BASF is the largest chemical company in the world, and today I'm responsible for circular economy topics and sustainability topics in West Africa. Now, how did that happen? Just for the students. I started by being curious about how things are made. Where do they come from and where do they go to? And so I pursued an engineering degree and started to really look at waste, how things were manufactured, right? How the human relationship with materials, right? And continued to dig deeper and deeper and found that it's not just a problem of technology. It's not just a problem of people. It's not just a problem of systems. It's a problem of all those things put together that have given us what we have today. And so we cannot just use one person's perspective. I, as a chemical engineer, I cannot solve all the problems, right? Even if I were to somehow come up with a magic formula that would give us ideal materials, that would not solve all the problems, because there's policy, there's engagement, there's several levels of intervention that are needed to really bring us back from where we are today, where the only metric was how can we make human beings as comfortable as possible, ephemerally, without thinking of, well, how can we continue to ensure that we're comfortable? Because I like to say something. It's not as though the earth is in danger. It's the fact that we're making the earth unconducive to human life, right? And all the consequences that come with that. So the earth can simply kill us off and it will be fine, it will regenerate itself. But do we really want to be boiling? I think not. So next slide, please. Right, so again, this is just the chemical industry, and it shows how, on top you see that petrochemicals, which is chemicals from fossil resources, are contained in 95% of all manufactured goods. So your clothing, your furniture, surface treatment, everything around you most likely has petrochemicals in it. And we keep extracting and producing and again wasting. So part of what we do, what I do at BASF is to think in value chains. So difference between value chains and supply chains. Value chains is how do raw materials become products. Supply chains is how do we get something from A to B, right? So if there are certain value chains that have been required to sustain human civilization, to improve the quality of life of human beings, and we assume that they are critical, how can we source materials from cities and re-inject them into those value chains such that we are not consistently pulling out new resources? So what I do is map pathways for circularity in the chemical industry and bring those to life. I start with pilots, I do scale-ups, and then just see how we can reintegrate those. Today, I'll explain this further later, but here, we start at the base. And when you're able to regenerate resources at the base, it means that you can really go the full length of manufacturing from regenerated resources. So what we do at BASF is we start at the base and we source crude oil fractions from plastics. So think of it this way. Plastics come from crude oil fractions. So instead of having to extract more, how can we simply take what is in the environment and convert it again, in ways that are now holistic and circumspect into the resources that we need to continue to drive those value chains. And I'd like you to take a moment to really appreciate everything up there. Of course, this doesn't include metals and some other value chains, but everything all up there, most of what you use today comes from petrochemicals, and it is important that we make this sustainable, because I'll tell you something. About half the greenhouse gas emissions that we emit today are tied to how we use and consume materials. So if we were able to make those more sustainable, more circular, we would make a huge dent in just one of the planetary boundaries, but then with ripple effects, we'd be able to make a huge dent and really bring us back from the verge of extinction. Next slide, please. Okay, so this is how I think of it. We look at a pile of plastics waste, because one of, like I explained, crude oil fractions generate plastics. So you can often get then building blocks for the chemical industry from plastics. So we look at a pile of plastics waste, and we begin to put on our chemical goggles, and instead of seeing trash, we see the individual components of the pile of trash. And how can we, instead of letting that become this big stinky pile of trash, how can we ensure that when it's generated, if it is necessary, we can harvest that and use those for the resources we need? So these are some of the questions I'm often asking myself. But an important one is, what is the total value content of a pile of trash? And we start to look at value differently. It's not just economic value, but it's economic, social, and environmental. Now, whenever I put forward a proposal, a business proposal for at BASF, I need to prove that it's a social venture. I need to prove that there's social value, there's environmental value, and then there's economic value, so that it is truly sustainable. Next slide, please. Okay, so these are some of the projects that I'm working on. First, waste to chemicals, literally plastics waste to chemicals. And an interesting thing is, part of the good things about working on problems that are relevant to us is that we can really bring our own perspectives. So imagine if we tried to take systems that worked in developed nations and try and transplant them immediately. They obviously wouldn't work, because we have a different context here. So one way that we've really looked at our interventions in plastics waste that has been beneficial has been to look at it from a decentralized perspective. So you often don't have the luxury of being able to move plastics waste long distances, because of course then we need to think of, again, consequences, but also the complex environments that we operate in. You'll kill your business if you do that. So what we came up with was decentralized, efficient, and effective systems that would be able to handle waste where it is generated, micro factories, and add value before you can then move it to other steps of the value chain. So where BASF would have originally thought of a gargantuan plant, we have a chemical complex in Germany that is that houses about 40,000 staff who work on just one chemical complex. Now we're talking micro units, 1 ton, 3 tons, 5 tons a day, strategically located in communities that can treat chemical waste and can generate valuable building blocks. And when I say communities, sometimes I get question marks. I would like to say that I spent 2 years at BASF sitting down, looking at this technology from the perspective of ensuring that it met the criteria for health, safety, and the environment, because we're not going to put into communities anything that is going to harm those communities. So for 2 whole years, trained engineers sat down, looked at every nut and bolt, and how do we do it in the right way. So that was waste to chemicals, our primary project. So difficult to recycle plastics, such as soft plastics that typically don't get captured in the plastics recovery and secondary raw material value chain, can now get captured more easily. Also, insecticide treated nets. I like to talk about this one. So up to date, about 400 million insecticide treated nets, mosquito nets, have been donated, distributed in Nigeria to prevent malaria in vulnerable communities. And all of that has ended up as plastics waste in the environment. Nobody has recovered that. But again, when we come in and we look at materials with our chemistry goggles, we see resources that can be recovered. So that's where we stepped in and we said, okay, what's really in these nets? We used our proximity as producers of chemicals that are used to treat the nets to say, let's take a closer look, what's really in these nets, and can we recover them? So we've started working on that in 2022, and what we've done is we've piggybacked off the donation campaigns to tell people, when you come to collect your new nets, bring back the old nets that you have in your house that you're not using, that you would have discarded anyway, and then we collect them and ensure that they go into recycling, into remanufacturing. So we've done that in a couple of states. We follow the distribution campaigns across Nigeria, and we optimize for each state. We're developing an evidence-based model to bring circularity to malaria prevention, so we can continue to save lives, prevent deaths from malaria, while ensuring that that does not have the consequences of open burning, marine pollution, and really negative effects to the vulnerable communities that you're trying to help. Right, so that's our second project. Now, this one is a bit touchy. Project STAR is mechanical recycling of food-grade polystyrene. Who knows what they call the styrofoam food containers? Those ones that were recently banned. So, interesting thing is BASF does not have a styrenics business on the continent, but you can't have a bunch of chemical engineers and chemists in a room and they don't start looking at things differently. And so we saw this thing that is such a challenge for local communities, if it is necessary, again, if it is necessary for them to use single-use plastics for whatever reason, can we find a pathway in the chemical industry for these? And then we connected to, you guessed it, the largest recyclers of polystyrene in the chemical industry, who are able to take everything that is generated as waste back as raw materials. And so we started a pilot in Lagos State, that was before the ban, to recover the materials and then send them to recyclers where they could be used for building materials, where they could be put to use and tracked to ensure that this is where the material is going at the end of life, what is going to happen to it, we're going to be able to recover it. So that's, I'm very proud of this project because it brought a solution to a menace that had affected urban communities in Nigeria, primarily for years. Because again, it's important to note that we were just having this conversation, we don't always have the luxury of developing the big infrastructure, of doing what developed nations have done. We have to leapfrog. And so that means that instead of necessarily building 20, 30 transfer stations. Sometimes that's not always possible. Sometimes you have to use waste sorting hubs. Sometimes you have to recover the value before it even gets to transfer station. So that's part of what we're doing. And the basis on which we connected with Pop Beach Club and Right on Beach Festival is that, like I said, we're always looking for pathways for secondary materials to go back into the chemical value chain. And today, BASF is able to off-take polyamide that is used to make nets, sometimes clothes. It's nylon, so nylon fabric. You might have heard of what we've done with Inditex, that's the parent company of Zara, to make recycled clothing then from polyamide waste. So we know that this has a value chain that we have built over the years. BASF is over 150 years old. We're going to be 160 next year. Right, so years and years and decades and almost centuries of developing expertise in chemicals. And so we're able to really look at the different parts of chemicals and say, where do we need to re-inject resources and what can we do with this? And so with Pop Beach, we are working to see where are the nets in Nigeria? What are they made from? Are they made from resources that can go back into the chemical value chains? If not, can we then influence design for recovery so that it doesn't end up as waste? And we continue to look for large volumes of plastics waste that affect communities negatively so that we can immediately see how can the chemical industry intervene today? How can I build a rail today to take this waste and make it a resource for the chemical industry? Next slide, please. Yes. So, like I said, now I have to prove that everything I put forward is a social venture. So we work with social entrepreneurs, people we've identified who know how to get the waste out of the cities or out of where it's generated to where value is going to be added, in the right way. We ensure that you're paying a decent wage to your waste workers. You are considering human rights in how you handle your relationships with your waste workers, and that you are empowering people. Now, these are the primary criteria via which we choose our partners. And so we work with social entrepreneurs who collect the waste. They know how to do it. They've been doing it for a long time. We are the chemical company. We know how to process it. We know the interventions to bring. And so we partner to then bring in these interventions and drive value and impact. Next slide, please. Yes, please, if you could play this video, I would really like for everyone to hear from some of the people that impact.
Baloma fún mi lówó owó tó bá ti wá fún mi nígbà mi ṣe business kékèké kan níbi ẹnu ọ̀nà ọ̀dọ̀ mi nílé business model ti ṣe yẹn ó fi ń dín kankan ní ara mi bí kì í fọ bá àwọn ìfẹ́ mi lọ sanwó ọkọ mi sanwó skul kò tó èmi náà fowó kún ọkọ mi fẹ́ ṣe ọkọ fún mi lówó yẹn òkè mi náà fi kún.
Gbogbo ẹ̀ bá ṣe ń ṣà wọ́n ń rà ni àwa náà dẹ̀ fi ṣe owó ọmọ skul torí kí lọ́mọ tó sanwó ìyẹn la kọ́kọ́ máa jẹ.
Àǹfààní tí mo rí bẹ̀ tó ń fún alára tèmi tó jẹ́ tèmi tí máa jí lójú mo máa ń jí pé mo máa ń lọ síbi iṣẹ́ tí mo ti máa ń rówó fún àwọn ọmọ ọmọlẹ́ni tí mo bí àti mọ̀lẹ́bí tèmi náà láti fi jẹun.
This project is very, very beneficial to everyone because it has helped control the environmental waste and clean up the environment at large, making Nigeria a better place for all.
Hello? Now it works. So it was really important for us to see that, because the premise of our solutions is that we're working with people who are able to collect the waste, who are able to go into the communities, waste workers who can have decent work, who can be dignified in their work. And it's important that as they go with their bag to that little pile of waste, they're not only taking a few bottles, they can take more. We can create more value, additional income for them, and ensure that they are earning a living wage. So, shameless plug for BASF Solutions. Now, at BASF, another thing we've done is, as a leader in the chemical industry, we can't run away from the fact that we've all been part of how we as humanity got here, right? So we've sold chemicals that have come from fossil resources, right? And if we were able to make business from the conventional ways of doing things, and we are willing to then also be the ones that create chemistry for a sustainable future, right, who are able to change the chemical industry, then we must be able to provide to our customers solutions that are circular. So chemicals that are based on circular materials. Because you would be surprised at the number of people who do not subscribe to circular solutions simply because they do not have options. And sometimes our customers, who are also manufacturers, need then the support to be able to manufacture based on sustainable chemicals. And so what we do is we promote then, or we champion our lines of products, and we're expanding our lines of products that go into circularity. Okay, so in addition to building our chemicals on recycled feedstock, on recovered feedstock, on regenerative feedstock, because again, recycling is just an immediate intervention. It doesn't take into account the whole perspective. But in that immediate intervention, giving our customers solutions that are based on these circular feedstocks, we're able to enable them in the green transition of the chemical industry. Because we do not serve people who buy from the FMCGs, but FMCGs who are manufacturing every day can do that based on sustainable materials. We also give them feedback. What you're putting out there sometimes is not recoverable. You need to work on that. So there's that. And also, if you zoom into the working group of people who are working to build those pathways back into industry, back into manufacturing, you often find technical challenges. So for mechanical recycling, which is today able to have carbon emissions over the typical phase, which would be incineration, open burning, as typically practiced in many parts of the world, we then have these loop solutions where BASF sits with you and says, what are your challenges in getting materials back, in processing materials back into the value chain? We have that little magic wand that I have on the table that allows you to identify 30 different plastics by type, textiles, different types of recyclables, and a whole circular economy portfolio. So if you need to then clean the materials, because this is often a need, where we are today in recovering materials means that it's often being commingled, right? So if you need to clean materials before they go back into the value chains, we have solutions for that as well. And if you need to enhance materials, right, but in a way that does not introduce novel entities into the environment, because again, planetary boundaries, we can't support you with that. So this is just an overview, like I said, shameless plug of BASF solutions for the circular economy. And then my final slide. So this one is more for the students again. So let's say we've intervened in 1, 2, or 3 ways. There's a whole system of problems out there, and there's a whole list of solutions to engage in. And well, while thinking of the whole list of solutions, we need to really sit back and also think of the elephant in the room. Today, developed nations have developed on the back of fossil resources, and today that's the path to development. Are we going to say to the developing nations, don't explore your fossil resources so you can't develop? What options are we going to give to them? I don't have all the answers, but this is why we all need to lend our voices to the challenge. I don't say to an oil-rich country, to an OPEC member, oh, stop exporting this thing that supports your economy. But then what are the interventions? What are the solutions? And so in the way that BASF is leveraging our position and our unique perspective to drive change, I will invite everyone here today to do their part.